Okay, so this lecture is in compensation for the lecture which I missed. So I will go through the solution of the exam problems, okay, which are from the lectures of um, traffic flow parameters and from spot speed studies. Then later on, I will also give a brief introduction about the concepts of capacity and level of service. So let us begin. So this was the first question in the exam of section 1. You were required to fill up fill up the missing values and then calculate the peak hour factor. So this one is very easy. You have the value before and after. You just take the average. So this will be the flow here, and for this one, as already mentioned, that then we take the difference of the previous values. So this one will be 400 plus 400, which is the previous value, minus 300, which is the value before this. So you have to calculate this one to reach to this level. Okay, so this one will be 500. Now if you want to calculate the peak hour factor, you need two things. You need volume. So volume is the addition of these. Okay, so it will be 200 plus 300 and plus 400 plus 500, which is 1400. Then peak hour factor is 1400 divided by 4 multiplied by the maximum of the flow, which is 500. So this one, and it comes out to be approximately 0.7. Okay, the next problem was this one. You were given an equation of flow and density, and then there was another equation given between flow and spacing, sorry, density and spacing, and you had to calculate these four things: jam density, capacity, flow and spacing when density is 20 vehicles per mile. So I'll start with this one, the last part. Okay, I find it more convenient. So when density is 20, then flow is 60 into 20 minus 20 square. Okay, so I'm using this equation. Okay, so let me get the value. It is 1000 vehicles per hour. For spacing, it was dA equals 5280 divided by 20, and this one comes out to be 264 feet. Okay, then for capacity, you will put this one as when you reach capacity, that means the slope of this equation should be equal to 0. So first of all, you will take the slope dv upon dt, then you take the derivative for the slope. It will be 60 minus 0.5 into 2 into density, and you put it equal to 0, and in this way the density comes out to be 60 vehicles per mile. Now for jam density, if you do 2 minus 60, because 60 becomes a critical value, so if you do 2 minus 2 into 60, that also is jam density. There's no problem with that. Okay, but if you want to find it from here, then for jam density you will put flow equals to 0, and then you will solve this quadratic equation for calculating the value of d. Okay, so if you solve this equation, then d should be equal to 120 vehicles per mile. So whatever method you apply, it doesn't matter, it will be considered correct. Okay, for this question I'll go to the Excel sheet so I can do it quickly. Okay, so for calculating the mean speed, upper and lower limits are given. You need to find out the middle one, which is the middle of these two. So 31, 33, 35, 37, 39, and 41, and then 43. And then you need to multiply n into s. So n is this one, the observed vehicle, and s is this one, the middle speed. If you multiply them, sorry, I could not give you to do it in Excel during the exam. It was not possible, obviously, but I can enjoy this tool as much as I want. So this is the summation of n into s, and then I need the capital N as well, which is summation of all observed values. So this is it. So I have 9696 here and 262 here. So I go there, I do mean equals 9696 divided by 262, and it comes out to be 37 miles per hour. Okay, so this is from the exam of section 1. If I go to the exam of section number 2, then this one is very easy. You have to do this. I'll go again to the Excel sheet and make a new file here. Okay, so all these values are for 12 minutes. I want to convert them to 15 minutes. You can see here all of them are 12 minutes. I need to convert them to 15 minutes. So what I will do is I'll take each value, divide by 12 because it's taken for 12 minutes, multiply by 15 because I want 15 minutes, and I will do this. Okay, I'll do this for all the values. Then I do the summation. Never mind the decimals. If somebody wrote 1s and 8 9s, there's no problem with that. Okay, then I go here. This is the other one. Okay, so I go there. So the volume is the total of these figures, which is 1789. 1789. Okay, and then peak hour factor equals 1789 divided by 4. As I told you earlier, the maximum is 594, so 594, and this comes out to be 0.79 approximately. Then I go to this question. Now here I will do it just straight from first to last because it's very simple. You need jam density. When you have jam density, speed equals to 0. So I'll take this equation, put the entire equation equal to 0, which is the speed equals to 0. Then d comes out to be 120 vehicles per mile. Okay, then you need free flow speed. For free flow speed, this d will become 0, so I'll again take the whole equation to just multiply this with 0. So my s comes up to 60 miles per hour, and then I do for average speed and spacing when density is 20. So for speed, I just put 60 minus 0.5 into 20. So this is 40. Sorry, this should be 60, and then this is 50 miles per hour. For spacing, we already used the equation for the previous example as well. It will remain the same. 5280 divided by 20, and it was 264. Okay, then we come to this case here. Again, you have to calculate the mean. Mean is again n into then the observed values multiplied by the values. So here the values are for the travel time. Okay, so if you want n into s, it will be 0 into 100 plus 120 into 2 plus 140 into 3 plus 160 into 5 plus 180 into 5 plus 200 into 1, so which means 200, then 220 into 5 plus 240 into 4. Okay, so this whole thing, I'll just do a summation here. So this comes out to be 4620. Okay, total number of vehicles we have 2 plus 3 plus 5 plus 5 plus 1 plus 5 plus 4. Okay, how many 5 we have? We have 2 plus 3 plus 5 plus 5 plus 1 plus 5. Okay, that's fine. Just put an extra plus here. So 23. Okay, so the mean will be 4620 divided by 23. Am I missing something? 2 plus 3 plus 5 plus 5 plus 1 plus 5 plus 4. Okay, that should be fine. Okay, so if I go there, if I do this upon this, it's 200.86 or 87. It's in seconds. Okay, so this is it. 120 into 2 43. Okay, that's a solution. And now we will begin with some concepts related to capacity and level of service in highway capacity manual. Okay, so I'll give you a brief introduction about the concept of capacity and level of service for uninterrupted flow facilities, and these are taken from chapter 7 and 28 of the textbook, which is the 5th edition of traffic engineering by Mick Shan and lots of other authors. And now you can see here that for my help we have some subtitles as well, which is a good thing. Okay, move on. Let us move on. So we have talked about traffic flow facilities. They are mainly of two types: uninterrupted and interrupted. Interrupted have intersections, uninterrupted ideally should not have intersections. But they are the condition in which highways with the intersections can also be called as uninterrupted. And that condition is when the intersections are more than 2 miles from each other. Then the part of the highway which is between these intersections can be called as uninterrupted. So if you take this into consideration, then the uninterrupted flow facilities can be of three types. There are three subtypes of uninterrupted flow facilities. The first one is freeways. So freeways are pure uninterrupted facilities. They don't have any intersections. So they fulfill the actual definition of uninterrupted flow facilities. Second one is multi-lane highways. Multi-lane highways are those highways which have intersections, but the intersections have more than 2 miles between them. So that part which is between the intersections is considered as uninterrupted flow facilities. Obviously the intersection is just a point, so most of the highway is uninterrupted. So that's why we discuss it here. So we have the multi-lane highways, and then we have two-lane highways as well, which will be considered as uninterrupted if they fulfill the condition of this spacing between the intersections of 2 miles. Okay, now so the difference between multi-lane highways and two-lane highways is the number of lanes. There's no other difference. Both of them have intersections. In both cases, the intersections have a spacing of more than 2 miles, and the part which is in this spacing is considered as uninterrupted. As far as the freeways are concerned, there is no two-lane freeway. So freeways are always having more than 2 lanes. Okay, so the difference between freeways and multi-lane highways is that freeways don't have intersections. Okay, 2 miles or whatever spacing. There's no question about spacing here. Freeways don't have intersections. Multi-lane highways have, and two-lane highways have, and the difference between the last two is the number of lanes. Okay, two-lane highways which are uninterrupted, like they are so long that they can have intersections with 2 miles of spacing or more than that. You will only find them in the rural areas. The reason is, in the urban areas, two-lane highways can only be used as local streets. Okay, The reason is the urban areas have more population, more traffic demand. So a highway or a street which is as narrow as 2 lane, you cannot use them and as a main highway, as an arterial or a collector. So while they are the local streets, that also means the intersections are very close to each other. So in urban areas, 2 lane highways are generally not found as uninterrupted. But in rural areas, okay, the traffic flow is less, so I can do with 2 lane highways. And since there's no crossing, no population, so intersections can be very far from each other. Okay, the concepts about level of service and capacity are given, or those which we will discuss are given by Highway Capacity Manual. So it's a manual which is published by Transportation Research Board, which is a very famous organization for the transportation professionals. They have they do an annual conference as well, which is considered very prestigious. They have a research journal, and obviously they also publish this manual as well. So this manual was published first in 1950. After that, you can see it has been revised and different editions have come to the market. The latest one is actually 2022. It's not mentioned here, but I just got to know about it afterwards after I prepared the slides. So the latest one is 2022. Okay, but the book we are using, McShane, the edition of the book we are using, only uses the 2016 manual, so we are still stuck with that. Okay, what will this manual give us? This manual has become a global standard for calculation of capacity and level of service. And I must mention that level of service is the concept which is given by the manual. Okay, this concept was introduced in 1965 by the Highway Capacity Manual. This was not available with any other standard with any other country. Okay, so as the manual developed from one edition to another edition, what happened was the calculations became more complicated, more factors were involved, equations became larger, the sequence became longer, and so on and so forth. So they thought that we should develop a software. So they collaborated with the University of Florida and they came up with a software which can help people do the calculations of the manual. It was in 1994. Maybe the software is still available, still in use, but it's no longer required to do the calculation of the manual. Why? Because other softwares, even if they are from other countries, they have adopted the calculations and the standards and the equations from the manual. For example, a very famous software, Vision, which is made in Germany, and it is used in Middle East as well, in many other countries across the world, even in Pakistan. So Vision uses the calculations given by the manual. Other softwares include Synchro, Paramix, etc. Again, they are from different countries and used in many other different countries, and all of them are using the calculations given by the manual. So the manual is now readily adopted, and there's no problem if you are using the manual, if you are using any software, and you don't have to worry about, if I want to follow the highway capacity manual, what will happen. You can still do it very easily, no problem with that. Okay, there's a story behind the 2016 manual, which is that in 2016 or before 2016 they said, okay, let us revise some of the equations and factors which we are using. So they came up with a research program which they call a strategic highway research program, in short, SHARP. So in this program they did a lot of research. The idea was to update some of the factors and standards used in the capacity analysis, but eventually they came up with so much data, they thought that just an update would not be enough, we should publish a new edition. And after that they got so encouraged that they are now doing it after every 6 years. This is what I heard. So some of the main aspects or the new aspects of 2016 manual was the concept of travel time reliability. So when you quote your travel time to someone, when you estimate a travel time from point A to B, it's not always the same value for each and every traveler. There's always a margin of error, there's always some variation. So there's always a concept of reliability. Okay, how much variation you can expect in the travel time estimate. So this concept was used. They also introduced the concept of managed lanes Managed lanes are those lanes which are exclusively used for a specific mode. For example, bicycle lanes, bus lanes, truck lanes, high occupancy vehicles, and so on and so forth. And then we have active traffic management strategies. We have discussed earlier that traffic volume changes every minute, every hour. So there are devices available which can capture this real-time data and convey it to you in the control center. Now, if you use this real-time data to do some real-time or active management of traffic, for example, changing signal timing, changing the speed limit, putting up road signs, if you do it in this manner or using real-time data and in a quick manner, then it comes under active traffic management strategies. In Bahrain, we see there are policemen who serve this duty of doing active traffic management on signals, from morning till evening. Okay, so this is our way of doing active traffic management. They don't know about this in the manual, otherwise they would have included it. Okay, so capacity is the maximum flow the highway can take. We know that, but there are some specific issues which you have to keep in mind when you are calculating the capacity. The first thing is capacity is not volume; it is maximum hourly rate, meaning maximum flow rate. Okay. Now, why is this important? We have discussed earlier that if you do not consider the fluctuation of volume within the hour, like how the volume is changing between 15 minutes interval within the hour, you may have a problem in even fulfilling the capacity of the highway, even if the capacity is equal to demand. This fluctuation can cause a short-term breakdown in the facility, and that will not let you fulfill the actual demand even if it is equal to the capacity. So when you consider capacity the maximum hourly rate, you are ensuring that the facility does not have a short-term breakdown as well. It does not break down even for a small period within the hour, for example 15 minutes or so. Then the other thing which they included was that capacity is for different facilities, and some of these facilities may not include vehicles, for example pedestrian bridges, bus systems, railway systems. So capacity, if you are talking about a highway, is vehicles per hour, a signal is vehicles per hour, but the other facilities can be persons per hour. A railway station, a metro station can have a capacity in terms of persons per hour. Okay, and then capacity is something which you reasonably expect. So it's not something like, it's not a hard limit that if you reach this, then you cannot go beyond it. You cannot, you will always fulfill this much. No, maybe the capacity which you calculated is 2000, but in real sense, in practical sense, when the vehicles even reach near 2000, they are below it, but they are very close to 2000. You may start seeing a breakdown and traffic jam and queue, and it can happen the other way around as well. Even when you reach 2000 and you go a little bit above it, still there are no signs of, or the breakdown has still not yet happened. Okay, but it does not mean that it will be off by a large number. It's not like I'm saying capacity is 2000 and I start having breakdown as 1000. This is seriously something wrong with the engineer who calculated the capacity. Okay, but in essence the value of capacity is a reasonable expectation according to the design of the road. Okay, which brings us to the second point, that the capacity of multiple points will remain the same if the points are part of a uniform section. Uniform section means the section characteristics are not changing. It means the design of the road is not changing, the speed of the road is not changing, and any other conditions are not changing. We will discuss these conditions now. So a series of uniform points have same capacity. Uniform meaning they have same design conditions, so they call them prevailing roadway conditions. They have same environmental conditions. So capacity on a clear day will be different than capacity on a foggy day or on a day which has very heavy rain. Traffic conditions can also affect capacity. The main traffic conditions that affects capacity is the percentage of heavy vehicles, trucks, buses, and these sort of vehicles. So their percentage affects capacity. The last thing is control conditions. Control conditions include the devices which you are using for controlling traffic. For example, signals, stop signs, speed humps. Okay, so an intersection which has a stop sign does not have the same capacity as an intersection which has a signal. Okay, so all these things affect capacity. So what did we say here? Capacity is maximum flow rate. It can be persons or vehicles. It is not a fixed number, it's a reasonable expectation. It does not change if the conditions of the road are uniform, and these conditions include the design of the road, the traffic conditions, meaning the percentage, mainly the percentage of heavy vehicles, the environmental conditions, and the control devices you are using on the road. Okay, this table gives us the capacity of the three uninterrupted flow facilities which we have discussed earlier: freeways, multi-lane highways, and rural two-lane highways. You can see here for freeways and multi-lane highways, it depends upon their free flow speed, and free flow speed is basically a measure of design speed of the road. So just to refresh your minds, free flow speed is the speed which is chosen by the driver when he or she is unaffected by traffic. So that happens when the traffic is low. I just explained to you, or I just solved the exam problems as well. So there was one problem where we had to calculate the free flow speed and we considered density to be 0 at that time. So no traffic. So it is basically an indicator or a measure of the design speed of the road. For two-lane highways, the capacity is fixed, 3,200 passenger cars per hour, but this 3,200 is not divided equally. It is divided 1,500, 1,700, 1,500 in one direction, 1,700 in the other direction. And what is the concept behind it? One lane can take 1,700 vehicles maximum on a two-lane highway. But the question will be, why the other lane is not taking 1,700? And the answer is, when one lane or one direction reaches 1,700, it has some effect on the other direction as well. So this effect stops the other direction from going to its full potential, which is 1,700. So that's why when one and this is very obvious, because if your lane reaches capacity, okay, so what you will do, some of you may go to the other lane and try to overtake from the other side. Okay, so you are affecting the other side, you are affecting the other direction. So that's why and because of the closeness of the two directions, this is a distribution which you can have maximum 1,700, 1,500. Okay, I was talking about ideal conditions, okay, and the road conditions which affect capacity. So I mentioned traffic. So you can see the ideal traffic condition is passenger cars per hour. So no heavy vehicles. Okay, the ideal traffic condition is only passenger cars per hour. PC means passenger cars. So we will discuss other ideal conditions later on. Okay, level of service, as I mentioned earlier, level of service concept was not traditionally used or was not available to the traffic engineers. They knew about three conditions, basically three traffic conditions: capacity of the road, the condition which you see at the capacity, the free flow condition, and the jam. Jam is not mentioned because of obvious reasons. So if you look at these conditions from the point of view of design, so I obviously nobody will design for a jam condition. Okay, jam is unwanted. So either you can design for capacity or free flow. If you design for free flow, that means it's an overestimation. Now design means what? The peak hour has this condition. So if the peak hour has free flow, that's a problem. That means the road was not required. Nobody is using the road even in the peak hour. So either it's not the peak hour, or either the road was overestimated. It was not required. Now what about the capacity? If you design for capacity condition, so the peak hour demand reaches capacity. So in this case, what will happen if the demand is exactly equal to capacity? Then you are saying that there is no margin of safety. there's no margin of error. Okay, so you are in dangerous grounds now. Okay, so this is unstable. Okay, so we have to define some intermediate levels between these conditions, jam and capacity and free flow, for which we can actually design the highway. So this is how and why they come up with the concept of level of service. So level of service is, or there are different levels of traffic conditions, okay, including capacity and free flow and jam, but it has other levels as well in between them. Okay, and to make it more fun, they said, okay, we will code the level of service from A to F. So we have level of service A and B and C and D and E and F, which is very familiar to the students of this course or students anywhere in the world. So they are very familiar with A to F. So that's why uh, these concepts became more fun. And as I mentioned earlier, that this concept was introduced in 1965. Okay, by the highway or in the highway capacity manual. Before that, there was no mention of a level of service. So this is where we'll stop, and inshallah we will move along further with this topic in the class. Okay, so thank you so much.